Okay, so this is that sheet for you to work on. I guess it serves as a review. Let me just make sure everything's working. Okay, here we go. So I saw some of you guys working on the first problem right off the bat. It didn't look good. So you have to really be careful here as how you approach these questions. So again, take that extra 5 seconds to, you know, uh, realign them, or what do you call? What's the word I'm looking for? Move them around so the like terms are next to each other. And if it helps, I mean, remember, you have a calculator, so if there's no at home, use a calculator too if you want. So the only thing I'm going to do is put a 1 in front of the A, because if it helps you remember that it's 1A, then why not? So these two are A's, right? So I can combine these two, and the other one will be in the middle. So that tells me that the two circles will go next to each other, and that rectangle will go to the end. So I'm going to move the content of the first circle, which is negative 8a here. The negative 1a I'm going to put right next to this, and I'm going to switch colors because that might be easier for you to see. And there's a minus 6. Okay, so now you're subtracting negative a minus 1a, so it's going to be something a, right? So let me change colors back. Going to be something a, and you're going to do in your calculator negative 8 minus 1. Now, you can enter it like that, or if it's easier for you to see it, you don't have to use a calculator. It's simple enough. So some of you might already know that that's negative 9. Some of you who still are not seeing this as easily, you can change that to an addition problem and make it negative 8 plus negative 1. And that tells you that they're both negative, they're friends, so it's just going to be a larger group of negatives, so it's negative 9. Okay, so negative 8 minus 1 should have been negative 9. And that minus 6 there is doing absolutely nothing, it's just decoration, but it's still part of your expression. Final answer, negative 9a minus 6. Take the time to take this step, to do this step right here, where I put in check marks to combine like terms, putting the like terms next to each other, and then combine them. So over here, same thing. And again, I'm going to put the 12v, 12v minus v, they're the same. The p's, I'm going to change colors. I'd rather do it with different colors. So negative 10p, and it's negative 13p, so they're going to be next to each other. And that 9 there is going to be left at the end. So let me write them. So it's 12v, so it's everybody in the context of everybody in the circle. So it's 12v, and this is minus v, or better yet, minus 1v. In blue, it's negative 10p, minus 13p, and then I'm just going to drag that plus 9 till the end. First one is easy enough. It's 12 minus 1, which is just 11v, right? In blue, it's negative 10 minus 13, so it's negative 23p. And again, so if I drag that to the side here, it's negative 10 minus 13. Let me put the p there. So it's negative 10p plus negative 13p. And they're both negative, so they're friends, right? So it becomes negative 23p. And then the plus 9, I just write it. So again, I know it sounds repetitive, but if you're not doing this line right here, you should be doing this line. Okay, you should. I really suggest you do this. Okay. You know what? I always forget I can make this bigger. There you go. Hey, there, you can see better. Negative 4k, and another thing that's k is the plus k. In blue, I have the negative 7m, and then the negative 21m, and then the negative 12. I'm just going to leave it alone. So let me write it again. Negative 4k, I'm going to bring the plus k, and then in front of the plus k, I'm just going to put a 1 there. Minus 7m, minus 21m, and then in another color, minus 12. So you can tell that this constant here is going to just hang around there doing absolutely nothing. So in black, these two, negative 4 plus 1k is negative 3k. In blue, it starts here, don't forget. It goes all the way here. So it's negative 7m minus 21m, which is going to equal negative 28m. And negative 12 just comes down. This is part of the expression. So your final answer is this. Negative 3k minus 28m minus 12. That's what I'm looking for. Or that's what you should be looking for. So again here, just to you need to look, this expression here, or this term here says 4a squared b cubed. So is there anything else that has an a squared b cubed? There is. These two are of the same kind, so they're like terms. So let's put them next to each other. Okay. And then we have a minus 9a. There's nothing else that's just a, so that goes, it's going to be by itself. It's going to do absolutely nothing. And lastly here, I have a minus 12b to the fifth power, and also not going to be doing anything. So you know these two last terms, this guy and this guy, will be doing absolutely nothing. So the only thing you have to worry about is these two. 4 minus 6 is negative 2, and don't forget to write a squared b cubed. Negative 9a will just be copied, and the negative 12b to the fifth power is also going to be copied. And this is your final answer. Okay. Distributive property. So again, distributive property, we're multiplying the two terms inside the parentheses times 5. So 5 is going to be multiplying these two. I'd like you to take care of the signs first. I just think that's easier. So it's a positive times a positive, so that's going to give you a positive. I'm going to write positive even though I don't need it. And 5 times 2 is 10, but don't forget the k, right? So I did see a lot of where you're not putting the k there, but the k has to be there, right? And then a positive times a negative, it's a negative, and 5 times 8 is 40. So your final answer, let's just make it a little neater, is 10k minus 40. This one, there's nothing outside the parentheses, but remember, I told you, pretend there's a 1 there. It makes it easier for you to see. So it's negative 1 times this, negative 1 times the middle term, and negative 1 times that last term over there. So again, signs comes first. Negative 1 times negative 7, it's positive, so it's just going to be, and 1 times 7 is 7m. Negative 1, so again, negative times a negative here on the 5a squared, so it's a negative times a negative, so it's positive, plus. And 1 times 5 is just 5, and don't forget the a squared. Very important for you to write your variables. And negative 1 times a positive is negative, and 1 times 9 is 9. Can I combine anything? No, they're all different. So this is it. Okay. Moving on. So this one, I had a couple of you ask me a couple of questions today about this. So we're going to multiply. So again, think about what this is. Okay. First of all, it's a positive times a positive, right? So I know my answer is positive, but look at what that means. Let me just write it here on the side. It's 2 times m, because that's what 2m, right? There's a little dot. Even though we don't see it, it's being multiplied. And then we're going to multiply that, and I'm going to put times 5 times w. So that's what this looks like, 2m times 5w. It looks like this. But we can clean this up. I can multiply the two coefficients here, and 2 times 5 is 10. And then I can write times m times w. So, and if I clean that up, it becomes just 10mw. I don't really need those dots. So 2m times 5w is 10mw. And likewise, if I multiply these two, well, first of all, it's positive times a negative, so it's going to be negative. 2 times 12 is 24. And don't forget the m, and don't forget the k. We always write it in alphabetical order. Okay, so the, oops. So I just bit my tongue there. We always write in alphabetical order, which means the k should be first and then the m. So 24 km. But this is your final answer. Last one over here. There is a parenthesis, but no number outside, so pretend there's a 1. This is easy, right? Because 1 times this is just going to be whatever is inside the parenthesis, the first term, and 1 times 3, they're both positive, so nothing changes. So it's going to be just 3m to the third power. And 1 times negative 4 wk, positive times a negative is a negative, and 1 times 4 is 4. And don't forget the wk. Okay, that's it. Now these are with fractions. Again, not a big deal. First thing we do is a negative. Take care of the signs. It's a negative times a positive, so it's going to be negative. What's 2/5 of 15? There's, like I said, that we talked about in class, right? There's a lot of ways you can do this. You can multiply 2 times 15 first, which is 30, and then divide it by 5, gives you 6. But 6m, don't forget the m. Next one is a negative times a negative, so it's going to be positive. And 2/5 of 20, again, 2 times 20 is 40. 40 divided by 5 is 8, so I get 8p. Negative times another negative here. It's going to be positive, and 2/5 of fifth. So it's multiply 2 times 5 gives you 10, and divided by 5 gives you 2. Right? So, and don't forget the W. Can I look at it? See if you can combine any like terms? There are no like terms. We're done. Excuse me. Again, same thing. 4/7 times 14m is a positive times a positive, so it's a positive answer. You can multiply 4 times 14 first, which is going to give you 56, and divide by 7, you get 8m. 4/7 times, positive times a negative is a negative, and 4/7 of 49. So we can, in this case, well, 4 times 49 is times 4, 6, 36, 196, and then divide that by 7. So 196 divide that by 7 is 2, 14, 56, 28. So that's going to give me 28b. And again, you have a calculator. Last one, positive times a negative is a negative. And you're going to multiply 4 times 28 and divide it by 7. Or, to make your life easier, you can divide 28 by 7, which is 4, and then multiply by the 4 on top, which is 16. 16g. And again, just look at it, see if there's any like terms to combine. There isn't, so this will be your final answer. Now this is almost. So use the distributive property and combine like terms. So you're definitely going to have to do both here. So let's take care. You always take care of the distributive property first, because that removes the parentheses. Positive times a positive is a positive. 3 times 2 is 6k. Positive times a negative is a negative, and 3 times 4 is 12m. This 12 and that, I'm not going to change colors here just to show you that the 12 and the minus 8k are not to be multiplied with this 3 here. This 3 is only being multiplied by everybody who's inside the parentheses. So the 12 and the 8k do nothing. Combine like terms if you can. So let's circle. If I see a like term, it's this 6k and the minus 8k. So let's put those two side by side. Let me bring that minus 12m, minus 12m, and then I'm gonna bring that plus 12 to the end, because these two, they don't have any like terms, so there's absolutely nothing to do with them, but they're part of the expression, right? So let's do these two. 6k minus 8k is 2k, and then I'm just going to copy the rest. Minus 12m plus 12. Like I said, that is part of your expression. Therefore, this is your final answer. Distributive property first. So 5 positive times a positive is a positive. So 5 times 8 is 40. And don't forget the a squared. Minus, and then, positive times a negative is a negative. And 5 times 12 is 60. And I'm going to change colors because just to show you that this distributive property was not applied to the minus 6a squared. Right? That term is outside the parentheses, so it doesn't, it's not being multiplied by 5. Do I have any like terms? I do see that this is an a to the second power, and this fellow over here is also an a to the second power. So let's put those two together, side by side, like that. And 6a squared, and then finally, I'm going to drag that minus 6a squared to the bottom. 60a. Minus 60a to the back. The only two that I have to combine is these two. And 40 minus 6 is simply 34. A squared minus 60a. These two are not the same. They're both a, but one is a to the second power, and the other one is just a. Okay. Okay, so this one has 2 parentheses and 2 distributive properties that I have to take care of before I can combine like terms. So let's do this. Positive times a positive is a positive. I get 2p. If you like to put a 1 in front of the p and a 1 in front of the w, it's the same thing. And again, a 1 in front of the p and a 1 in front of this w, you can. It makes no difference. Positive times a negative is going to be a negative, and 2 times 1w is just 2w, right? 2 times 1 is 2. Let me change colors. This is a negative 3, so think about it, okay? Negative 3 times a positive is a negative, and 3 times 1 is 3, and I get Last one is a negative 3 times negative w, so it's going to give me positive plus, right? And negative 3 times 1 is 3w. 3 times 1 is 3w. Combine like terms if you can, or if there are any. And let's see, there is plenty actually. This one and these two are the same kind. So 2p minus 3p. And finally over here, 2w minus 2w and plus 3w are of the same kind, so they will be next to each other. Combine like terms, 2p minus 3p is negative 1p, or just negative p, which is actually the better way to write it. And then minus 2w plus 3w, it's going to be plus 1w. So in actuality, you actually should write it like this. Right? It's redundant to write that there is 1p when we only see 1p, right? So these two mean the same thing. So if you've done this, it gets, I could give you credit as well as this. I am getting a sore throat. Okay, so first thing I think if you see an expression like this, I would do this only to recognize that this is where the distributive property is happening among these three. And everybody else is just hanging out there and waiting. So the 12 is going to do absolutely nothing. The minus 6h is going to be doing absolutely nothing. And here's where the distributive property happens. So it's a negative 4 times h, or 1h. And negative 4 times h is negative 4h. Negative 4 times negative 7. So it's a negative times a negative, which is a positive. And 4 times 7 is 28. That 9h, again, it's doing absolutely nothing, so I'm just going to write 9h. Okay, so your distributive property is happening here, nowhere else. Okay. Let's do combine like terms. Let's see. Okay, I find that this guy and this guy over here are the same, so I'm going to write those two side by side. Oops, and I'm sorry. And this guy too, and minus 4h. And then the other two, 12, and what kind of 12 is that? It's a positive, so I'm going to write plus 12 and plus 28. So, combine like terms. Let's combine these three, negative 6 plus 9, negative 4. Negative 6 plus 9 is going to be positive 3. Positive 3 and negative 4 is going to be negative 1h, which is negative h. And then this is a positive 12 and positive 28 and plus 40. All right, the better answer would have been, or just a neater answer would be negative h plus 40. Again, this took me 1, 2, 3 steps, and that's what I suggest you do it. You know, especially this step where we're moving all the like terms next to each other. I highly suggest you do it. Moving on. I need to just make a little bit more room. Okay, so again, if you want to, and I'm just doing this so that you know that the distributive property is happening here with between these guys. That's one, and you're going to have to do the distributive property again. But notice that it's not the 4. The 4 is not being multiplied, because if that was, the 4 would be right outside the parentheses. So you notice that in front of this parenthesis there are no numbers, so I'm just going to put a 1 there. Right, and then that tells me that these two are going to be multiplied, and these two are going to multiply. Okay, so set your problem like that in the beginning. It just might kind of help. So 9k is just doing absolutely nothing. So still part of the expression. Bring it down. And let's do the distributive property. So it's a negative times a negative, which is a positive. And 8 times 3 is 24x. And then it's a negative times a negative, which is a positive again. And 8 times 4 is 32k. Alright, so now I'm going to change colors. And minus 4. Actually, let me change colors. Minus 4, okay, it's doing nothing, so this guy in the middle is doing nothing. And then I have, what color can I use? I can use orange. That negative 1, so it's a negative times a positive, which is a negative, and 1 times 4 is 4k. Negative times a positive is a negative again, and 1 times 5 is a 5. So, that's my expression. Combine like terms. Let's see if we can combine anything. Do I have anything that's a k? Yes, I do. I see this guy's a k, and I see the 32k, and I see the minus 4k. So all those three will be next to each other. 9k plus 32k minus 4k. Then I have an x here. So I'm going to write circle that in red, and I'm going to write plus 24x. And finally, over here at the end, I'm going to circle the minus 4 and minus 5. So those two will be combined. So why did not? Okay, so just change it to black. Minus 4, minus 5. So all my like terms are next to each other. So let's combine them. So it's 9 plus 32, which is 41. And 41 minus 4 is 37. So that becomes 37k. Then plus 24x, and the x, there's nobody else, so that just comes down. And then I have, be really, really careful here. Negative 4 minus 5. If you can see that this is negative 9, great. If you can't, change it to an addition problem. And you see that they're both negative, so it becomes negative 9. So it really depends. If you can't see this, that's okay. Change it to an addition problem, and that might help you understand why we get negative 9. So it's really up to you. But again, remember, you have a calculator. Okay, so if you put in minus negative 4 minus 5, it will give you negative 9, and that's the answer. So all this that we started with becomes a very simple expression with 3 terms. Okay. Next, well, it's fraction, right? So it's okay. Negative times a negative is a positive. And then we've got to do 5, 6 times 6, right? 5, 6 times 6. It's going to give me 5 times 6 is 30 divided by 6. So this is going to be 5m. Negative times a negative again is going to be positive. And 5, 6 of 24. So 5, 6 times 24. It's going to give me 20. Negative times a negative, it's going to be plus. And 5, 6 of 12 is going to give me 10. And then I'm going to switch colors because I want you to see that the minus 23 and the minus 17m were not part of that distributive property. Okay, so they're just out there hanging out. Now that the parentheses are gone, I got to look to see if there's anything I can combine, and I can. Please don't just leave your answer here because then you will not get a full credit. So now you look to see if there's any like terms. There's one. And this guy are like terms. And these guys in the middle are of the same family too, right? So let me move the circles around. So 5m and minus 17m are together side by side. And I'm going to write all the other three. Plus 20, plus 10, and minus 23. So those three needs to be combined. So again, calculator, 5m minus 17m. You don't really need it. You can really tell that's 12m negative. And 20 plus 10 is 30, and 30 minus 23 is 7. What kind of 7? You can't leave it like this, because we're missing an operation here, right? So it's going to be plus 7. That's, so all this here simplifies to that. Okay. Ooh, I need to, now here is your bonus word. Your bonus word is going to be this, Wacom. That's the company that makes the tablet that I'm using to write on my laptop, because my laptop's it's not a touch screen, so I need to hook up a tablet and use a pen. And they're a pretty good company, okay. And that's the name. So that's your bonus word. Okay. Moving on. So again, the questions. Gets a little larger, but it really just means that you have to be neater, more careful, make it more difficult. It just means that you just have to be more careful. And again, I'm going to start off by just pointing out where the distributive property is going to happen. That's going to be one of them. And the other distributive property that's going to happen is going to be here. Okay. And notice that the negative 5m, again, it does nothing, so we're just going to write it over here, because it's part of the expression, right? We can't throw it away. Now, let's do the first one. So it's a negative 1/3 times 30. And so it's going to be negative times a positive. It's a negative. And what's 1/3 of 30? It's 10. Don't forget that m there. Next one, it's a negative times a negative, so it's a positive. And what's 1/3 of 12? It's going to be 4, but 4k. So that is done. Next, the second set of distributive property. Negative 2/5 and negative 35 is going to give me a positive. And 2/5 times 35 is going to be 14m. The last one, negative 2/5 plus 10k, is going to be negative. And 2/5 times 10 is going, 2/5 of 10 is going to be 4. 4k to be more precise. Combine like terms, this guy, and this guy, they're all the same. So I'll put them side by side. And you notice that I'm not going to circle the other two because they're the same. So it's plus 4k minus 4k, right? This guy, this guy, and this guy. Right? So they're not side by side. So again, we can do this mentally. You can do it in a calculator. It's really up to you. Negative 5 and negative 10 is negative 15. This two become negative 15. Now we do plus 4, negative 15m, sorry. And then plus 14m is going to be negative 1m. And these two is 4k minus 4k, which is just 0. I don't even have to write 0, so that just becomes 0. So they cross each other out. And my final answer is negative 1m, or better yet, negative m. Either this or this, completely acceptable. Another question where there is no numbers outside the parentheses, so just to help yourself, write a 1 here. I'm going to write a 1 here. Okay, I think it's easier that way. Again, I'm going to show you where the distributive property happens. It happens here, and there's a second distributive property that's going to happen between the 1 and 7k and the 1 and the m there. So let's do the one in blue. Well, it's a negative times a positive, so it's a negative, and 1 times 4 is 4, but 4m. Negative times a negative is going to be a positive, and 1 times 9 is 9k. Done. But let me do the other half. It's a positive times a positive, and it's going to be a positive, and 1 times 7 is just 7k. And then the second one is positive times a negative, which is a negative, and 1 times m is just negative m, or negative. And I'm going to start not writing that 1 there because you really don't need that 1 there. Okay. So combine like terms. This guy and this guy. These two are side by side. Negative 4m minus 1m, or just m. And then the other two is going to be plus 9k plus 7k. So I'm going to make a point here that if you guys write this and you forget this, it's going to look weird. Right? It's going to look weird because you're going to have, let's say you don't write any signs, you're going to negative 4m minus m, 1m blank, there's like nothing here. And then 9k plus 7k. So we need that plus sign. Combine like terms, so this says negative, so it's going to be something m. And then negative 4 minus 1 is simply negative 5. In red, you have a positive 9 plus positive 7, and 9 plus 7 is just 16k. Do not leave your answer again like this, because I'm missing a sign here, and the sign here is plus. That's it. And then, we have the sequences. And again, so you must by now be really tired of doing linear sequences. I definitely want to move you guys to quadratic sequences. So instead of giving you a picture this time around, I actually I gave you the numbers. So imagine a pattern where they had 4 squares, and then 9 squares, and then 14 squares, 19 squares, and 24 squares. So imagine I gave you that like I usually do in class, and I asked you to find the rule, right? So the first thing we do is find the first difference. So the first difference is going to tell us what kind of sequence this is. Well, 4 to 9 is 5, 9 to 14 is 5, 14 to 19 is 5, and 19. So this is again, what kind of sequence? It's a linear. First of all, it's a linear sequence. So if we were to graph this, and we're eventually going to get there, this sequence is going to look like a straight line. Okay, not that particular straight line, but it's a straight line with a positive slope. So what kind of sequence is this? Is a 5n sequence. It's a sequence that goes by 5s. Now think about what a 5n sequence goes. The 5n sequence is a sequence that, think of your times table, where your first number on the 5n sequence, well, if substitute this n was 1, 2, 3, 4, 5. So at the first sequence in the 5n sequence is 5 times 1, which is 5. The second number would be 5 times 2, which is 10. And we'll put a comma here. This third number in the 5n sequence would be 15, and then it'd be 20, and be 5, etc. Right? So now think about what we have. I have a 5n sequence where the first number is 5, but I really don't want 5, I want 4. The second sequence, the second number in my 5n sequence is a 10, but I don't really want a 10, I want a 9. The third one is a 15, but I don't want a 15, I want a 14. So what adjustment do I have to make to 5, 10, 15, 20, 25 to actually get 4, 9, 14? You notice that to go from 5 to 1, 4 is minus 1, from 10 to 9 is minus 1, 15 to 14 is minus 1. 20 to 19 is minus 1. So your sequence is a 5n sequence. So this is a sequence that goes by 5, but there's a minor adjustment of minus 1. So think about this. So if you have 4, 9, 14, 24. So let's say I wanted to ask you, what number would this be? Well, without drawing or using a pattern, this is the first, second, third, fourth, first, second, third, fourth, fifth, sixth number. So what would be the sixth number in this sequence? Well, I can use my rule. So here's my rule. My rule says it's a 5n minus 1 sequence. So the sixth number over here, well, I would substitute that n with 6, and I get 5 times 6 minus 1. So 5 times 6 is 30, and 30 minus 1 is 29. So the sixth number of my sequence would be 29. And we know is that correct? Yes, it is correct, because 24 and we add 5, we get 29. So this rule here, with this rule here, I can find any number in my sequence. So let's say we keep going in our sequence and I asked you, what is the 54th number in this sequence? So if I were to ask you, well, you can go and keep adding 5 and keep adding 5 until you get to the 54th number, or we can use this sequence. So again, the 54th number in that sequence, well, I would use the rule that we just found, which would be 5n minus 1. I substitute n was 54, so I get 5 times 54 minus 1. And 54 times 5 is 20, goes 270. So it would be 270 minus 1, which would be 269. So the 54th number in my sequence is 269. So with this rule, I can find any number I want. And that's what I'm looking for. Next one. Again, let's find the first difference. So again, that's our first job, find the first difference. And if we go 13, 21 is 8, 21 to 29 is 8, and 8, it looks like 8, and looks like 8. So this is a sequence that goes by 8. So it's called an 8n sequence, right? How does an 8n sequence go? So the first number on the 8n sequence would be 8. The second number would be 16. The third would be 24, 32, 40, etc., right? So it's an 8n sequence, but I need to make an adjustment to this 8n sequence because I don't really want an 8, I want 13. I don't really want 16, I want 21, and etc. So what adjustments do I have to make to each of these numbers to actually get these numbers, the original sequence that was given to us? So what can we do to the 8 to become a 13? What can we do to the 16 to become a 21? So for each of these numbers, to get this top number, we must add 5. So our rule is going to be, well, it's an 8n sequence, but with a minor adjustment that I have to add 5 every time. So if you think about it, look at this. Let's substitute. So our first number is 13. Let's see if that works. Well, using this. So 8n plus 5. And if I asked you to find the first number in an 8n plus 5 sequence, our first number would be what? You substitute 8 times 1 plus 5. 8 times 1 is 13. Sorry, 8 times 1 is 8. Plus 5 is 13. Is that what we get here? Yes, our first number is 13. First, second, third, fourth, fifth number. The fifth number of that sequence is a 45. Let's see if we get a 45. So it's always nice that you can, what do you call, double check with your sequence. So we have the rule. And we want to find out what the fifth number is. Well, we're going to change that n to 5. So 8 times 5 plus 5. 8 times 5 is 40. And plus 5 is 45. Is our fifth number in this sequence of 45? And yes, it is. So if I asked you for the 20th number, right? So if I did this and I said, okay, let's go for it and figure out what the 20th number in this sequence would be. Well, you can obviously write it all out, which would be a little bit tiresome. Or you can use the rule you found and say, well, the 20th number, so 8 times 20, right, times 5, because 20 at the end represents that particular term, right, the position, and we're looking for the 20th number. So 8 times 20 plus 5, 8 times 20 is 160, plus 5 is 165. So if you were to continue this sequence, 13, 21, 39, 37, 45, 50, what is it? Are we going by fives? Yeah. 50, 55, 60, etc., etc., etc. Our 20th number would be 165. Much easier doing this than actually writing all those numbers now because it's just much easier. Let's do another one. I'll do 2 more actually. Time for some honey and halls. So, first difference. So when the first difference is the same, it is a linear function. Okay. 14 to 26, 6, and again 6, 6, and 6. That means this is a sequence that goes by 6. So it's called a 6n sequence. So a 6n sequence, what's the first number in a 6n sequence? The first number in a 6n sequence is 6. What's the second number? 12. Third number, 18. Fourth, 24. Third, 30, etc., etc., right? So I'm looking at this, and if you look at, so although it's 6, I don't really want a 6, I want a 14. So I have to make an adjustment to this 6 to get to 14. I got to make an adjustment to 12 to get to 20. I got to make an adjustment to 18 to get to 26. And you'll notice that that adjustment is the same for each of those terms. So how does a 6 become a 14 plus 8? How does a 12 become a 20 plus 8? So this sequence here is a sequence that goes by 6, but I have to make adjustment and add 8 to it. So the rule or the function is a 6n plus 8. You can always double check to see if you're right. So let's pick the third number. The third number is 26. Let's see if I use this rule, I get a 26. If I don't, I know my rule is incorrect. If I do, then it's correct. So the third number is supposed to be 26. So let's substitute out 3. 6 times 3 plus 8 plus 8. 6 times 3 is 18, plus 8 is 26. Ah, it worked. Let's try it again. Our fifth number on my sequence here should be a 38. Well, let's use the rule, 6n plus 8. And I want to know if the fifth number comes out to 38. So I'm going to substitute that as 5. I get 6 times 5 plus 8. 6 times 5 is 30, plus 8 equals 38. Look, it works. So I know that my rule is 6n plus 8. And like I said before, we can find any number that we want using that rule. Okay. One more. First difference. First difference, 11, 23 is going to be 12, and then it looks like it's 12 and 12. So it's always going to be 12, 12, and 12. So it's a sequence that goes on by 12. So it's called a 12n sequence. And let's start and see what a 12n sequence goes. Well, so 12 times 1 on a 12n sequence, the first number is 12. Right? On a 12n sequence, the second number is 12 times 2, which is 24. The third number is 12 times 3, which is 36, and then it's 48, and then it's 60, and so forth and so forth. So I have part of my rule. So I know my rule is going to be a 12n, but let's see if that's enough. So my first number is 12, but I don't really want a 12, I want an 11. So I have to make an adjustment, right? My second number is 24, but I don't even want 24, I want 23. So I have to make an adjustment to this sequence to get to that. So what's the adjustment? And you'll notice that the same adjustment I have to make to each of them, it's going to be subtract 1. Double check. So let's pick this one. The fifth number has to be a 59. So if I substitute the n with 5, which is because 59 is my fifth number on the sequence, I should get 59. So 12 times 5 minus 1. 12 times 5 is 60. And minus 1 is 59. There is my number. And it's 59. And it works. So pick another one. Let's pick the second one. My second number on this sequence should be a 23. Well, if I use my rule, will I get a 23? Well, again, here's my rule, 12n minus 1. If I substitute this with 2, I should get, so the second number on this sequence should be a 23. Let's see if I get that. So 12 times 2 minus 1. 12 times 2 is 24. Minus 1 gives me 23. So I am right. So again, I can use this rule to find any number in my sequence. So again, if I go like this, and I go like this, and I say, hey, what is the 30th numbers in this sequence? Let's pretend that's the 30th number. What is that number? Well, again, you can list them all out and figure out what the 30th, or use this rule. So by using that rule, I get 12n minus 1, the right rule. So I want to figure out what my 30th number would be. I put a 30 in there. So it's going to be 12 times 30 minus 1. 12 times 30 is 360, I think. Yeah, 360 minus 1. And that number comes out to be 359. So the 30th number in this sequence here would be 359. Okay? That should be it. And we'll end it.